Hi everyone, my name is Justice Archer from the Bristol Aerosol Research Center at the University of Bristol. This is a brief highlight of our poster based on single droplet drying kinetics and particle formation from aerocolloidal suspension microdroplets. The aim of this study is to provide a comprehensive experimental data that will help us understand how process parameters such as temperature and relative humidity affect aerosol droplet drying kinetics in the gas phase, and how these gas phase conditions as well affect dry particle morphology, which are mostly encountered in spray drying applications. In order to do this, we combine two experimental techniques using the EDB and the falling droplet chain instrument. The EDB allows us to measure the droplet drying kinetics under different gas phase conditions, different temperature conditions, and relative humidity conditions. Knowing this kinetic data, with the knowledge of this kinetic data, we then match the same drying conditions on the falling droplet chain instrument and dry aerosol droplets of the same composition and observe the final and collect the final dry particles and study them offline using scanning electron microscopy. Most often, dry particles are described by the Teclanoma, which is given as a ratio between the evaporation rate and the diffusion of the solid particles in the droplet. This then allows us to somehow correlate the drying kinetics of the aerosol droplets in the EDB to the dry particle morphology that we obtain from the falling droplet chain instrument. With the use of the EDB, we are able to measure evaporation rates of different droplet composition under different RH conditions at different temperature conditions. Using this data, we are then able to describe the Teclanoma as a function of temperature, relative humidity, and particle size. Then, taking into account that viscosity changes when you change temperature and the vapor pressure of liquid also changes when you change temperature, we are then able to create a Teclanoma map where we can select some Teclanoma points which is based on drying conditions measurement and use them on the falling droplet chain instrument. So here are some examples of some data that we obtained from the falling droplet chain instrument with prior knowledge of drying conditions. As you can see, with smaller Teclanomas, we observe spherical particles, and as we increase the Teclanomas at given drying conditions, we're able to obtain folded particles. So generally, by combining EDBs and the falling droplet chain, we are able to study the entire lifespan of droplet drying under different conditions. There are also interesting data in the poster, and I will encourage all to take a look at it. And if you have any questions or if you have any comments, I'll be glad to answer them. Thank you very much.